Hello, fourth grade families. Very good to see you again. Let's get right to what we are doing this week in math. On Monday, we worked on addition, specifically in word problems. On Tuesday and Wednesday, we have started already with our PLT sessions. The focus of these PLT sessions has been subtraction. However, students seem to be very excited about being able to go at their own pace and decide what they're going to learn and focus on. So please ask your student about how they feel about PLT and what they think about the new structure. On Thursday and Friday, we will go back to our usual structure in which we're going to focus on subtraction, on the composition in particular, decomposing in particular, which is when you have to borrow from the place value to the left in order to subtract. We'll see it on an example in just a minute. All right, let's get to what we did on Monday. The first part of the word problems that they're going to ask you on Monday is to estimate an answer. Again, the first part in the first part of the word problems for Monday, they're going to ask you to estimate an answer. This is done through rounding. So that's when we apply what we did last week to estimate an answer and get a good sense of whether we're close or not once we have solved the whole word problem. The second part, or a very important part of the word problems that you're going to be working with this week, have to do with a tape diagram. A tape diagram is a visual representation of a word problem that can really go a long way in helping students understand the information given in a word problem. This is a huge deal for me, and it should be, I think, for all of us. Having taught in fourth grade and third grade, the processing of the information that a word problem has always been a stare for our students. I really think that the use of a tape diagram will really help students visualize and record the information better. At first, I was not very sold on the idea of a tape diagram, but now I'm a huge advocate because I have seen how students basically they have to focus a lot more on the information that they're given, and they have to process it, and then they're able to work with it with so much more ease. So let's look at an example of a use of a tape diagram. We have a word problem here. It says, last year Macy's sold 118,214 pairs of boots. 37,092 more pairs of sandals than of boots were sold. And 124,417 more pairs of sneakers than pairs of boots were sold as well. How many pairs of footwear were sold? As you can tell, the wording of the problem is even a little bit confusing, right? Even for adults. That is why it's so important to process the information for students. So let's see how we would do this with a tape diagram. Let's see. Boots would be about something like this. We get 118,214 pairs. Sandals, we know that is 37,092 more pairs of sandals than of boots. So we're going to have the same bar plus another smaller bar that is 37,092. And lastly, 124,000 more pairs of sneakers than pairs of boots. So again, we start with a bar of similar size, 118,214, and we add another similar bar, because in this case it's a little bit bigger, of 124,417. Now, I know that it's a little bit awkward sometimes to ask for a tape diagram for these cases, right? Especially from the point of view of an adult that has worked with math on a daily basis. you read this problem and you just decide, oh, I have to add, right, to figure out the answer of how many pairs of footwear were sold. However, trust me, a visual representation of the word problem, and it's also a visual representation that we're going to use this whole year, will go a very, very long way so that students are able to solve word problems and process the information a lot better. So after you do this, then you set up the problem. Hopefully, the inference that students will make after making this tape diagram will be that they have to add all of them together, and that's when they start. You can add it in pairs or all together. It's up to the student. But basically, we're using the standard algorithm to add them up. So line up the numbers vertically and then add them up. That's a little bit of what we did last week. All right, so now let's go over to what we're going to do on Thursday and Friday, and what students have already gotten a little bit of a head start during our PLT sessions. We have a word problem here. Jason ordered 239,021 pounds of flour to be used in his 25 bakeries. The company delivering the flour showed up with 451,202 pounds. How many extra pounds were delivered? All right, so let's work on our tape diagram to start. How many were ordered? This many. 239,021. How many were delivered? It says 451,202. So the number is greater than our order number. 451,202. Now, the question is, how many extra pounds were delivered? So basically, it's asking us for the difference, right? So that extra space is what we have to figure out. Now, as you can see, this visual representation will help students think or try to figure out what operation they need to do to solve this problem. Hopefully, they'll arrive to the conclusion that they have to subtract. They may still need a little bit of help thinking through the problem, but that's where we want them to get to, and that's what the visual representation aims. We have a larger number, we have a greater number, we have a lesser number here. We have to figure out the difference. So then we use the strategy that we learned in school when we were younger. 451,202 minus 239,021. Again, check to make sure that your student is aligning the place values correctly. Make sure that the ones are with the ones, the tens with the tens, etc. And two, make sure that the smaller number is under the greater number. The deeper reason that you can talk to your student about is that in order to figure out the difference, you have to take out 239,021 from 451,202. That is the deeper reasoning that we want them to get to, and that's why the smaller number goes under the greater number. However, you can also go to a more practical reasoning, which is that in subtraction, we always want the lesser number to be at the bottom. 2 minus 1, 2. 10 in this case, 0 becomes 10. 2 becomes 1. 10 minus 2 is 8. 1 minus 0 is 1. 1 becomes 11. 5 becomes 4. 11 minus 9 is 2. 4 minus 3 is 1. 4 minus 2 is 2. And that is our answer. Of course, we want students to write a full sentence answer. Okay, that's all for today. Please focus on the use of tape diagrams for this week. We will continue to use it throughout the whole year. Thank you very much, and please reach out if you have any other questions.